Good day everyone, my name is Jericho R. Jose from BIT2K Set B, here to explain to you all the things you need to know about engine control unit. But first, what is an engine control unit? An ECU, also commonly called an engine control module (ECM), is a type of electronic control unit that controls a series of actuators on an internal combustion engine to ensure optimal engine performance. How an engine control unit works. It controls the engine by reading values from a multitude of sensors within the engine bay, interpreting the data using multi-dimensional performance maps, called lookup tables, and adjusting the engine actuators. So, this is an example showing that the mass airflow sensor and the throttle position sensor is telling the ECU that the engine is at 40% engine load, and the crank position sensor is telling the ECU that your engine speed is at 3000 RPM. The ECU then looks up the AFR, which means air fuel ratio, value for 40% engine load at 3000 RPM, and compare it with the AFR value that is coming from the oxygen sensor from the exhaust system. It then makes the necessary adjustments to make sure the engine is running the way it's supposed to. So if the AFR value coming from the oxygen sensor is 13%, the table says it's supposed to be 11.5. So the ECU knows that the engine is running too lean. So it sends the signal to the fuel injectors to stay open long enough to add more fuel to the mixture to make the AFR value into 11.5. There. And this is the multi-dimensional performance map, or the lookup table. This is where the ECU base its calculations, whether or not the percentage is proper to any type of calculation it will make. Like, for example, the idle stepper lookup table for the EVO 8. What the ECU controls in the engine: air fuel ratio, idle speed, and variable valve timing. Air fuel ratio. Most modern engines use some type of fuel injection to deliver fuel to the cylinders. The ECU determines the amount of fuel to inject based on a number of sensor readings. Air fuel ratio. Oxygen sensors tell the ECU whether the engine is running rich, too much fuel or too little oxygen, or running lean, too much oxygen or too little fuel as compared to ideal conditions, known as stoichiometric. Air fuel ratio. The throttle position sensor tells the ECU how far the throttle plate is opened when the gas pedal is pressed down. The mass airflow sensor measures the amount of air flowing into the engine through the throttle plate. The engine coolant temperature sensor measures whether the engine is warmed up or cool. If the engine is cool, additional fuel will be injected. Idle speed. Most engine systems have idle speed control built into the ECU. The engine RPM is monitored by the crankshaft position sensor, which plays a primary role in the engine timing functions for fuel injection, spark events, and valve timing. Idle speed is controlled by a programmable throttle stop or an idle air bypass control stepper motor. A full authority throttle control system may be used to control idle speed and provide cruise control functions and top speed limitation. It also monitors the ECU section for reliability. Variable valve timing. Some engines have variable valve timing in such an engine that ECU controls the time in the engine cylinder at which the valve opens. The valves are usually opened sooner at higher speeds than at lower speeds. This can increase the flow of air into the cylinder, increasing power and fuel economy. ECU sensors. The list of ECU sensors are manifold absolute pressure sensor, intake air temperature sensor, mass airflow sensor, crankshaft position sensor, camshaft position sensor, engine coolant temperature sensor, oxygen sensor, throttle position sensor, vehicle speed sensor, and knock sensor, and acceleration pedal position sensor. Manifold absolute pressure. The manifold outlet pressure sensor provides instantaneous manifold pressure information to the engine's ECU. The data is used to calculate air density and determine the engine's air mass flow rate, which in turn determines the required fuel metering for optimum combustion and influence the advance or retard of ignition timing. Intake air temperature. The intake air temperature sensor determines the temperature in the suction pipe and forwards the voltage signals arising from the temperature to the control unit. This evaluates the signals and influences the mixture formation and the firing angle. Mass airflow sensor. The air mass information is necessary for the engine control unit ECU to balance and deliver the correct fuel mass to the engine. Air changes its density with temperature and pressure. In automotive applications, air density varies with the ambient temperature, altitude, and the use of forced induction, which means that mass airflow sensors are more appropriate than volumetric flow sensors for determining the quantity of intake air in each cylinder. Crankshaft position sensor. A crank sensor is an electronic device used to monitor the position or rotational speed of the crankshaft. This information is used by engine management system to control the fuel injection or ignition system timing and other engine parameters. Camshaft position. The cam sensor can be used in combination with a similar crankshaft position sensor to monitor the relationship between the piston and valves in the engine, which is particularly important engines with variable valve timing. Engine coolant temperature. A engine coolant temperature sensor is used to measure the temperature of the coolant antifreeze mix in the cooling system, giving an indication of how much heat the engine is giving off. Oxygen sensor. To measure the exhaust gas concentration of oxygen from the exhaust of the engine to calculate and, if required, adjust the air-fuel ratio so that the catalytic converter can work optimally and also determine whether the converter is performing properly or not. Throttle position is a sensor used to monitor the air intake of the engine. The sensor is usually located on the butterfly spindle shaft so that it can directly monitor the position of the throttle. Vehicle speed sensor. Vehicle speed sensor, or VSS for short, is a type of tachometer. It is a sender device used for reading the speed of a vehicle's wheel rotation. It usually consists of a toothed ring and pickup. Knock sensor identifies the high-frequency engine vibration characteristics of knocking and transmits a signal to the ECU. The aim is to obtain the maximum energy yield by starting ignition as early as possible. Engine with a knock sensor can reduce fuel consumptions and increase torque. Acceleration pedal position. Transmit the position of the accelerator pedal to the engine control unit. Based on this information, the load requested by the driver can be implemented immediately. ECU actuators. ECU actuators are battery, idle air control valve, ignition coil, and fuel injector. Battery. This powers the whole system from the sensor to the actuators and the ECU itself. Idle air control valve. The idle air control valve, IAC for short, is located on the throttle body of fuel-injected engines, where it works with the vehicle's ECU to electrically regulate airflow to the engine to ensure smooth idling. Ignition coil. Subsequently, the ECU interprets the signals and direct the ignition coil to send a high voltage to the spark plug igniting the fuel air mixture in the combustion chamber. If any of the ignition components are malfunctioning, the spark will not be timed properly and the engine will not be able to start. So the ignition coil is a very great upgrade from the distributor because unlike the distributor in which it needs additional components added to the engine and more moving parts, an ignition coil works more better because it can be separated from each cylinder and it's electronically linked to the ECU for better spark timing than a distributor. Fuel injector supplies fuel from the injector pump to the cylinder. The ECU controls the pulse width of the injectors by using electrical signals. So here is the full layout of what is connected input and output of an ECU. This is the throttle position map. The T-map sensor, coolant temp, exhaust gas oxygen sensor, crankshaft position sensor, camshaft, oops, sorry, detonation sensor or the knock sensor, throttle position, and idle air control valve are both connected in the throttle body, battery, fuel injector are the output, so is the ignition coil, and idle air control valve. Thank you for listening.